Hi friends, welcome back. Now let us see how an element in a doubly linked list can be searched. So we have doubly linked list with some number of nodes. The first node is called the head and the last node is called the tail. Each node consists of three components, one the data component and one pointer to the next node and one pointer to the previous node. So this way we can make a bidirectional movement possible. So the code would be, so we give the position where the doubly linked list begins, the first node address, and then the key value which we are searching for. So we need to move from node to node. So to make that movement possible, let us copy the address of the head into a pointer called current. And then to know where exactly we could find that, so let's begin with a position variable which is equal to 0 and then start traversing. So as long as the current is not null, that means as long as we don't reach the end of the doubly linked list and the current node's data is not equal to x, just increment the position and then keep moving to the next node. So we start from the head, current is the head, and if the current is not null, that means if that uh, is not the end and the current node does not contain the value what we are looking for, then we just increment the position and move to the next node. So this keeps going on till either the first condition fails or the second condition fails, because this is connected with an AND operation. So as long as both are true, this loop continues. So either the first one breaks, then uh, we stop it. So if the first one breaks means the first condition is not true, means we have reached end of the linked list, or if the second condition fails means we have reached to a node where the data is x itself, so we break it. So we don't know where we have stopped this loop, so just verify that if the breaking condition was the first one, then we just verify if the current is equal to null, that means we have reached the end and still we have not got any of the value we are looking for. In that case, just return -1. That means we have reached end and till then we could not get anywhere the value we are looking for. Therefore, we just return -1 saying that sorry, we could not find the value yet in the list. Otherwise, return position +1. Why position +1? Because we have initiated with 0, so the first node is known by position 0, second node position 1, third node position 2, and so on. So value of position is 1 less than the actual position because we are starting from 0. Therefore, if we want to have our convention, then we call this first node, this called second node, this is called third node. Whereas the machine thinks that this is node 0, this is node 1, this is node 2, and so on. So to make this conversion from machines version to human version, we just add a 1 and that we return it. So that's how the searching is made possible. So let us check that how we are doing that. So we have created a node which is a node for the doubly linked list. So having two links, one forward, one backward, and then we are putting this. So as long as either we reach end of the list or we reach a node where x value is found, we keep on moving further and each time incrementing the position where we had begun our position value equal to 0. And if we don't reach the position where we get a value x and we reach end of the list, that means we could traverse from first node to the last node and nowhere we could find x, then we just return -1 and declare that element was not found. Otherwise, somewhere we would have broken. So this first breaking possible was current equal to null, then we are talking of this. If current data is equal to x, then we come out here and say that the element is found and it is found at this position. Yeah, we using the same logic of creating the nodes. So we create a node called new node, allocate memory for that, and write the data into the data position and then uh, forward and backward pointers point to null. So we create a node, call it head, give a number 18 to that. Then we create another node with the value 15, which we call is the second node. And then we create the appropriate reverse directions. And we create the third node, which we give a number 8. Then the fourth node, which is 9. And the fifth node, which is having a value of 14. And in each case, the previous links are appropriately created. And before searching, we just print what we are having in our linked list, and then we ask the user to type a number which he wants to search. So if that number is available, we get the answer. It is available at so and so position, and if it doesn't contain that, then we get that element is not available. So let's just check what happens. So the list here we have created is 18, 15, 8, 9 and 14. So if we say we are looking for say 14, yes, it is available in the linked list. The location is 1, 2, 3, 4 and 5. So I should get a answer that the element is found at location 5. So element found at position 5, yes, done. Now let's try once more. Now try with 18. Now I should get a answer that the value is found at location 1. Yes. Now let me try once more. Maybe trying to search 8 now. So 8 is found to be in the third position. So yes, it is in the third position. Now that's all good. If as long as I keep typing any of these 5 numbers, I keep getting. But what if I type something other than that, like 1? So 1 is not found here. So I should get an answer saying that 1 is not found. So we say that element is not found. So that way you can talk of any element which is not available. So maybe 16, I hope 16 also not available. Yes, not available, and so on. So that's how we work with searching. The searching starts from the first node and keeps on going. So it is possible that it may be available anywhere on the way from first node to the last node. So it takes order of n, worst case may be available on the last node, or if it is not available, then we have to make sure that each of the n nodes is verified before declaring that such a node does not exist. So whatever be the case, the worst case time complexity of this method is order of n. Yeah, somebody claims that when we are working with bidirectional thing, doubly linked list, is it possible to start searching from both the ends? So we start searching from the front as well as from the tail. From the head we start searching, from the tail we start searching. And can this search operation be completed in order of log n? That was a common question asked, and the answer is definitely no, because what we are doing is we are moving one step forward from the head and one step backward from the head, and simultaneously we are looking at two values, either this is what we are looking for or this is what we are looking for. So if we keep moving one side in one direction, other side in the other direction, then in the worst case it may take half the number of values. So that means if there are n elements, then the worst case it can take n by 2, and still we call it order of n. It cannot become order of log n. Then somebody claimed that if the things are in order, then we could have done it. But of course, that is not possible with the linked list, because linked list we have to traverse from node to node, node to node. You just can't find out where the midpoint is without traversing from one node to other node. Therefore, it's impossible to get a order of log n time complexity in case of linked lists, even in case of doubly linked list. Yeah, it can be a order of n by 2, but n by 2 also is considered to be order of n only. So that says that it is not possible to have optimum searching possible even if it is ordered list. Yes, in case of arrays, it was possible because there was possibility of random uh, assessing, whereas here it is not possible. Random access is not possible. We have to go sequentially from one node to other node because they are not available in contiguous locations. Therefore, we can't just take midpoint and all that as we could do in arrays. So that is a major challenge we have when we are working with arrays. So yes, the answer for this question is no. This cannot be solved in order of log n. It has to have order of n only. So that's it about searching. The next thing would be traversal, the same logic, but only thing is at each step we just keep on printing what the value we come across. So we can start from the head and keep moving using the forward links and keep printing that till we reach end of that, or we can start from the tail and go in the reverse direction using the previous links till we reach this null. So we start with this head and reach this null. So what we print is 2, 4, 6. But if we start from the tail and go till this null using the previous links, then we start with printing 6, 4, and then 2. So that's how the printing is done. So that's how we call it traversing a doubly linked list. We can traverse in both the directions. So it is easy to print either in forward direction or in the reverse direction. Both are equally possible. So that's it about with different methods available for doubly linked list. The advantages, let's look at it, what advantages we have for this. So one thing is, as just discussed, it's a bidirectional traversal is easily possible. Efficient deletion is possible, flexible insertion is possible, efficient reversal. So that means you can read in any direction from head to tail or tail to head with no complication. So reversal is easily possible. Instead of starting from the head, if you start from the tail and use the previous links, then the whole list can be reversed very easily, efficiently. And this will be very commonly used in implementing the complex data structures. We look in detail as we go into the further data structures like trees and graphs. Yeah, definitely bidirectional things will be of much use and very much useful in dynamic data management. Yes, nothing comes freely. They do have some disadvantages. Number one is extra memory is required compared to array as well as a singly linked list. Compared to array you need a space for storing data only, but in singly linked list you need space for storing data as well as space for storing the address where the next node is located. But in case of doubly linked list, we need one more space that says where the previous link is located. Therefore, if you compare with array, we need two extra spaces for storing addresses, one for the forward, one for the backward. Compared to the singly linked list, we need one additional address to store the previous links. And these elements are stored randomly in the memory. So accessing these have to be done serially, one after other. They have to be done sequentially. So you have to start with either head or tail and keep moving from one node to other node. And there is no possibility of direct access or random access is impossible, and hence it is a time consuming process. And traversing a doubly linked list can be slower than traversing a singly linked list. Then implementing, maintaining doubly linked list can be more complex than singly linked list. Yes, every time we need to make sure that whenever a new node is created, we need to make sure that two links are properly aligned. If something goes wrong, if we neglect something, then it's going to create a big problem. So implementing doubly linked list is definitely more challenging compared to the singly linked list because we need to manage two links. One should go to the forward, one should go to the backward, and making that intelligent arrangement is essential here. So there are some disadvantages of using the doubly linked list. So that's it for now. So that's about doubly linked list. So the next session we start looking at what a circular linked list is, and it's required, why it is required, the need for it, and advantages, disadvantages, implementations, more details coming soon in the coming sessions of this series. So till then, keep watching. If you find it worth, please don't forget to like and share with your friends. Please subscribe to the channel. Thank you.